Myself Samir Mane. In the last video lecture, we discussed on tidal energy, which is a part of renewable energy sources. Today, we will discuss on geothermal energy. Let's see. In the geothermal energy, the steam from the earth crust is released towards the earth's surface. From this steam, the turbine will get rotated, and from this rotation of the turbine, the generator will also get rotated. This rotation of the generator, we will get the power or the energy. This power sent towards the main line, and from the main line towards the further applications. This hot steam sent towards the cooling tower in the cooling tower deals with the condenser. This hot steam is a get condensed, and this steam is converted into the water and further inject in the reservoir or the earth crust. This is the principle of a geothermal energy. Let's see in a detail geothermal energy. Geothermal energy is a heat derived within the subsurface of the earth. Water and or steam carry the geothermal energy to the earth's surface depending on it. Characteristics: geothermal energy can be used for heating and cooling purpose or be coupled to generate clean electricity. Geo Geo means earth, thermal means heat. This is a combination of the Greek word. Its source lies 6,500 km beneath the earth's surface. Core containing hot molten rock known as a magma. Surrounding the core is a mantle, and the, the outer layer is a crust. What happens in this? The outer layer of the crust is covered with ocean water, and similarly the rainwater. The both waters will get percolate in the earth crust, and there is the formation of water pockets known as the water reservoir in the earth. Then deals with the magma and the volcano. These water pockets will get heated and steam is generated. Then this steam is used as a geothermal principle. Let's the crust is not a solid shell but is broken into pieces called plates. Magma comes close to earth's surface near edges of these plates. Rock and water beneath the surface around these region absorbs heat of this magma. We can dig wells and can use this heat for various purposes. Let's see the cross section of earth crust. Deals with this digging, we can release the steam for a power generation, and also send the cold water in a same reservoir. Let's see the history of geothermal energy. The use of geothermal energy for heating purpose is not new. In olden days, people are used it for heating and bathing by hot springs. Using geothermal energy to produce the electricity is new industry. In 1904, firstly, the Italian peoples used this energy. They were used the natural steam erupting the earth to power a turbine a generator where it get. In some visible features of geothermal energy are volcanoes, hot springs, geyser and fumaroles. But we cannot see most of the resources as they are deep underground. Survey is done by digging well and testing. temperature deep underground. Most active resources are found along edges of the tectonic plates. Ring of fire. An area called ring of fire has most of geothermal activities. This area borders the Pacific Ocean. Its uses. Historically, the application of geothermal energy were space heating, cooking and medicinal purpose. Types of its use. First one is a direct use. In that, geothermal heating, cooling and its further applications. Then the second one is the indirect use. Its use is a electricity production. Let's see the indirect use, electricity production. Source temperature is higher than 150 degrees Celsius. Deep wells are drilled and steam from reservoir is used to drive turbines and produce electricity. Let's see the diagram. There is a lower layer is a magma. Upside of the magma there is a water pocket. This is known as a reservoir. Deals with this magma. This water is get heated and transformed into the steam. Then this steam is drill out on the earth surface and sent towards the turbine. Deals with this steam, the turbine will get rotate and deal with the rotation of the turbine, the generator will also get rotate. Then deals with the rotation of the turbine, the power is generated and this power is transformed into the transformer. And from the transformer, this power sent towards the main line and further application. Then the hot steam is sent towards the condenser for condensation purpose. Then this condensed steam sent towards the cooling tower. In this cooling tower, this condensed steam is get cooled down and settled in a water form, and this water is again injected in the earth crust, that is in reservoir. Let's see the direct use of the geothermal plant. Heat is directly used. Heat is extracted from low temperature source, that is less than 150 degrees Celsius. It can be used for space heating, industrial processes, drying of crops, hot water supply, melting of snow. For space heating, heat pump is used. It uses little energy for heating, thus saves money and reduce pollution. Types of power plants. First one is a flash steam plant. Second one is a dry steam plant. Third one is a binary power plant. And the last one is a hybrid power plant. Let's see one by one. The first one is a flash steam plant. In this, hot water at high pressure when released from deep reservoir forms high pressure steam. That is nothing but flashed steam. This steam drives turbine. This is the most common type of a plant operating today. Then dry steam plant. Usually geysers are the main source of dry steam. Reservoirs which produce steam with small quantity of water use this type of a plant. A rock catcher is used to protect turbine from rocks coming along with steam. Then binary power plants. In this, the geothermal water is passed through heat exchanger where its heat is transferred to secondary liquid. Liquids having lower boiling point are used as secondary liquid such as isobutane, isopentane or ammonia water mixture. The vapor of secondary liquid are used to rotate turbine. The binary system is useful in geothermal reservoir which are relatively low in temperature. Heat loss is minimum as the system is completely closed. Hot water is immediately recycled back into the reservoir. The working fluid is also condensed back to the liquid and used over and over again. Hybrid power plant. It uses both boiling water as well as the steam. Steam is used as in flashed steam plant, while energy of hot water is used through secondary liquid as used in binary system. Let's see enhanced geothermal system. It refers to variety of engineering techniques used to artificially create hydrothermal resources. In this, the drilling is done in hot dry rocks and cold water at high pressure is pumped in. As water travels through cracks in hot dry rocks, its temperature is increased. Now, this very hot water is collected back through the another drilled hole, converted into steam and used. This is a very promising technology but is still in its development stage. Risk of seismic activities could increase due to artificially fracturing the underground rocks. Let's see the advantages of geothermal process. Geothermal energy is versatile in use. It is cheaper than zero fuels and fossil fuels. It delivers greater amount of net energy from its system than other conventional systems. It is least polluting system than conventional system. These plants are having the highest annual load factor of 85% to 90% compared to 45% to 50% for fossil fuel. The greatest attraction of geothermal energy is its ability of multiple use from single resources. Disadvantages of geothermal energy. Number one, the overall efficiency for power generation is low, is about 15% compared to 35 to 40% for fossil fuel plants. The withdrawal of amount of steam or water from hydrothermal reservoir may result in surface subsiding. Drilling operation is noisy. Large areas are needed for the exploitation of geothermal energy as much of its diffused. The steam and hot water gushing out the earth may contain H2S, CO2 and NH3 and radon gases. If these gases are vented into the air pollution will be. Geothermal energy in India. India has about 10,000 megawatt of geothermal power potential which can be used. More than 300 hot springs locations are to be finalized by Geological Survey of India and are grouped into geothermal province of India.